All right, here's another exponential problem. A population of bears decreases exponentially. What is the annual factor of decrease for the bear population? Explain how you know. Using function notation, represent the relationship between the bear population B and the number of years since the population was first measured, T. That is, find the function f so that B equals f of T. Okay. So, decreases exponentially. That tells me a little bit about what I'm looking for. That tells me that I know my relationship is going to be some sort of a fraction because it's decreasing exponentially, which means that, oh my gosh, what's going on here? Decreases exponentially, it's going to be a fraction. And that fraction is going to be raised to an exponent. And that exponent is going to be my input value. Okay. Because it's going to be like a half times a half times a half, or a third times a third times a third. So the trick here is figuring out like what fraction is that common multiplier, and that is what this, when it says annual factor of decrease, that's the like what's the fraction that we're looking for. Okay, so let's look at this. I did a little bit here. So all right, so I looked at this graph, and I made a little table. Time in years, which was T, bear population was B of T. And then at 0 years when we started, there was 400 bears. And then at year 1, there's 320 bears. And because this to me, right here, looks like a perfect point. Which means that it looks like it's exactly, it's exactly 320, comma, oh my gosh. Input first. Input is 1. 1 year, 320 bears. Okay. So then from here, I need to do a little calculation. So from 400 to 320, I'm going to multiply by something. So to figure that out, I'm going to do 320 divided by 400, and that gives me 0.8 or 4/5, if that's easier. So then I'm going to go ahead and check and make sure that the next one makes sense. So 320 times 0.8, using a calculator, I get 262.4 because I multiplied times 0.8 and 200. Does this number seem close to 262? Yeah, I think it does. Thereabouts. 2.4. Yeah, it's a little bit under that. It's close enough. Okay. All right. So my annual factor of decrease is 0.8 or 4/5, or, well, I'm not going to do percents because it's a 20% decrease, but it's 80% of the total. That gets confusing. I hate percent decrease. Okay. Using function notation, represent the relationship between the bear population B and the number of years since the population was first measured T. That is, find the function f so that B equals f of T. Okay. The other thing, okay, so decreasing exponentially, it's also like how many did you start with? So the starting amount, it's going to be however many you started with times the fraction, times itself the number of years it's been going. So the fraction raised to the exponent, and then times the starting amount. So here, you can name your function whatever you want to. I'm going to name my function B of T. You could name it f of T. I don't care. B of T, I start with 400, and then I multiply that 400 times 0.8 raised to the T power. Okay, that's how I would do it. I hope this is helpful. And we're just going to keep looking at these in the in the homeworks, and eventually we'll get it. It's fine. If you just practice, we'll get it. Great. Okay, have a good day.